Ask AuxEn Anything. And this is as I just said, this is the 10th episode. And this is an online platform where we have the civil structural engineers interact with us and ask their doubts, queries related to projects or any steel or RCC concept or about any construction or site issues. So we started late today, so I begin by apologizing for that. And because I just came back from the work and just entered home and then started this live streaming. So therefore, it got late today. So today's questions, I will also be looking. I mean, I have not seen those before. I didn't get time to check these questions, what have been asked. So let's see what are the questions and let's try to answer them. So what I'll do is I'll just share the screen and let's begin by answering the questions that have been asked on email and on the Google form first. Then we can take up questions from the live comments. So let's begin then. I'll just paste the questions that were asked. So let me just, what I'll do is, yeah. Let us take this first question that was asked by Mr. Tosh Agrawal. He is from Raipur. And his question is, I'll just copy and paste it over here first. So his question is how to design the hipped type roof in RCC slab, and he has shared one image also. So let me put that image also in front of you. Yeah, so he's asking these types of pitched roofs, how to do it in RCC, because in steel it is somewhat easier to do such things in in steel, but how to do that in RCC, that is his question. So any one of you has ever done such kind of a thing, designing these types of pitched roofs, RCC pitched roofs for any of their projects? Okay, so see, the just a minute, I'll just figure out a few things. I just told you that I just came back from work and I could not arrange a lot of things today. Yeah, so two parts. Let us try to answer this question in two parts. First will be how to do analysis, and then let us see how you can do the design. So now if you ask me this first thing, how to do the analysis of such a thing, so there is no appropriate codal provision that we have got in IS 456 for such types of shapes, because IS 456 only deals with, let's say, your rectangular slabs, that too supported on all four sides. So for such items or for such geometries, if you see, there are no proper codal documents available. That is one point. So in absence of such documents, what do you do? Now, what do we do? What I do for such cases, and if you refer textbooks also, what they say is that because of this geometry itself, so because you have the pitched roof geometry, maybe you have got some supporting system over here, or maybe you don't have a supporting system, but because of this geometry itself, because of these folds itself, it gets credible support lines over here. So because it gets proper support lines, or for example, if I were to talk about this thing, so it will get a proper support line on this edge, it will get a proper support line on this edge, and the base, if it is resting on this edge of this roof, then it will get a proper support line at the base also. So there are enough and sufficient support lines available, if you see, because of the geometry itself, and all these folds can also be considered as a good support line. So while doing analysis, an easy way is that once you have the support lines, you can assume a one-way behavior. Okay, of course that will be, in fact, assuming a one-way behavior will give you a conservative result. You are not considering the behavior of this slab in the other direction, you are just considering the slab behavior spanning between these support lines. So you can assume a one way behavior. I am saying this is what I do usually. So assume a one way behavior and then find out the moments. Once you assume the one way behavior, it is easy. You can assume some uh, approximate moments. You can refer IS 456 for some approximate moments. So that you can do. Or if you're not happy with this type of an approximate analysis, then you can do the actual modeling of such things in a software. So you can do the modeling in software. You can create such a geometry in ETABS or STAD. ETABS will be better because there are very good modeling options for such types of geometries. So if you are using ETABS for modeling such things, you can use the extrude options that are available, extrude, line to area options that are available, line to area. So what you can do is you can model this line and then extrude it in the other direction. So you will get a pitched roof very easily made. Or you can use the longer approach by making some elements like this between points and then doing the meshing. Whatever you do, you can the point to understand over here is that you can easily model it in a software like ETABS and STAT, apply the loads, and then design for the moments M11, M22 moments. You can design for it. So if you are not happy with manual approximate analysis methods, then you can use the software for modeling and get the moments and then design it accordingly. So these automatically become your support lines, and then you can detail these support lines. Uh, like a beam, also you can do it. So, for example, here if you see, they have provided some additional reinforcement in this in these regions because they are acting as your support lines. So anyway, so analysis is done. You get the moments. You can find out the steel and accordingly provide the reinforcement arrangement over here. Essentially, if you are considering it to support on these two support lines, let's say, then essentially the steel will be more of a one-way unidirectional steel that you will arrange. Okay. Some specific detailing requirements, if you ask me for such things, can be if I were just to show you SP34, it has got some diagrams for such arrangements. So let me just show you SP34. Let's see if we are getting something. SP34. As far as I remember, there are some diagrams covering pitch troops. Mm, Give me a minute, please. I'll just try and search. Someone remembers where you might get it. I don't know, this laptop fan is making a lot of noise. Okay, so if I were to show you, if you're hearing a buzzing sound, it is coming from this laptop fan. So something like this, if you see, something like this arrangement you can provide in your pitched roofs. Okay, and then Actually, this is not from a pitched roof, but anyway. So some arrangement like this you may provide, and then these become your support lines over here. So here you may provide some beam-like arrangement in these support lines, and rest of it can be done as a one-way slab or a two-way slab. Of course, that depends on the position of support lines. So I think this is how you can provide pitched roof. So to summarize a long story, what I will tell you is that analyze you just do it in a normal manner. Just take the span of your pitched roof, and just as you calculate the bending moments, just calculate it as a simple one-way behavior and find out the reinforcement and provide. Most of the times, that much is sufficient. Okay, that process is sufficient. Whatever steel you get would be sufficient and appropriate. All right, just give me a minute. Yeah, so I was facing some problem with my laptop. That cooling fan was going crazy. Anyway, so I hope that is clear how to deal with these pitched roof type of things. Now let us move to next question, and this has been asked by Mr. Ketan Mahajan. So he is joining from Jargaon, Maharashtra, and let us see what he has to ask. Okay, so he has two or three questions. I'll just copy it and let's try and answer them. So his first question is how to calculate the wind forces for a circular uncladded building. And he has shared one image. So let me just put that image uh, over here. Okay, this is interesting. Right. So this is his building, circular plan. Maybe some octagonal. Actually, it's not circular. It seems to be a one, two, three, four, five, six, seven. Maybe a octagonal plan or a hexagonal plan. And he is asking how to calculate the wind forces for such a geometry. So see now, if you ask me, there is no direct codal provision that is available for this type of a structure. So in wind, you always have to work your way through the different tables that are available. Okay, now that table may suit your requirement. Sometimes it may not suit your requirement. Sometimes you may have to use a wind table as per the 875 part 3. Not exactly suiting your requirement, but that is the closest that you have. So such things are a problem when it comes to wind load application. Now suppose if I were to show you this code, let us see which table comes nearest to our case. Remember that it's an uncladded building, so there is only sheeting on the roof. There is no sheeting on the side walls. Okay, so sides are open. You only have the sheeting on the roof. So now which table comes closest? So I think maybe this table comes closest, but this is again for rectangular plans. If you see this table number 13, let's see if any other table we can get it. I think this you can use. Table 9 comes closest to what we have. Okay. Again, remember that the key plan for this is square, or sorry, rectangle. But in our case, we don't have a rectangular plan. Our plan is hexagonal. But then, in absence of any data, uh, in absence of any other information that your code provides, I think this is the best we can have. Uh, and someone can just comment over here that can we use this table, or is there any better table that we have? I think this is the best suited table in our case. For those who are just who are watching or who have just started watching right now, what we are looking at is to apply wind load on such a such a geometry. Okay, so it's an hexagonal plan, and you have got this type of structural arrangement, and of course there will be sheeting over here. All these will be sheeting. So now how to apply loads, that is his question. So we are struggling to find out what geometry or what table in 875 part 3 we can use to apply wind loads on this condition. So let's see what do we get. So this table 9 is for freestanding double sloped roofs. Remember, our slope is not double slope, it is having multiple slopes. But then, except for this table 9, I don't see any other table which comes close to what we have got. And because we don't have cladding, it's a case of a freestanding roof. And that's why I think table 9 is the best that we have got. Okay. Yeah. So let us try to use table 9 over here. And just a minute, where is it? Table 9. Yeah. So this is the table 9, and our case will be this. How to use this table? Our case will be this. Now solidity ratio, because it is everything is covered by sheeting. So whatever is the total available area, all of that is covered. So you are getting a solidity ratio of 1. Now whatever is your roof angle, again it will be difficult to define a roof angle, but with any horizontal plane, you just find out the roof angle, and as per the roof angle, you decide your. So we will have to go with a positive roof angle. Okay. And whatever is your roof angle and whatever is your phi is 1. So accordingly you will calculate the coefficient. So this will be CPE. Negative sign will indicate that the wind pressure will be acting away from the roof. Will there be any internal air pressure coefficient? So there will be no internal air pressure coefficient, because it's a case of uh, unclad structure. So we don't have any CPI. Okay. So we just have the CPE, and that is what you will apply. All right. And then there is another case that you also need to consider, which will be, so if this is my roof, CPI means acting away. So this will be case 1. Sorry, CPE negative would mean acting away from the roof. So for example, my roof is 20 degree. For example, phi is 1.3. So you apply 1.3, 1.3. This becomes your case 1. Then you take another case. And this time you will apply a coefficient towards the roof plus coefficient. So you make these two cases, and accordingly you apply the wind loads. So this is the closest I think we can get for the type of geometry that we have. Okay. This is the best that 875 part 3 can give you. And then of course you apply it on purlins if you want. So if you want to apply it on purlins, you apply it as UDL, and wind pressure multiplied by CPE multiplied by the purlin to purlin spacing. and you can apply it as UDLs on these purlins. Okay. How to account? His next question, Mr. Ketan Mahajan is asking, how to account for the vibration loads near railway lines for designing a structure. Now, I have been asked this question in the past, but in any of the practical projects, we have not faced such a situation. So, see, if you want to be extremely technically correct, if you want a extremely technically correct answer, then you will have to find out the time history of the vibrations. Okay. So with passing time, what is the expected amplitude, that you will have to find out. So you will need a time history of the vibration. That time history you apply it on your structure, and then whatever outputs you get from that time history, accordingly you will have to design. Of course, then you will have to ensure that the time period of your structure does not create a condition of resonance. So that is the technically correct answer if you ask me what comes to my mind. But in many of the cases, what I have seen is people try to go for isolation more than trying to design for these vibration loads. So what I've practically seen is, suppose this is your railway line, and let's say the train is expected to pass on your track from here. Okay. And suppose you are going to construct a, or you have a house over here. Okay. Whatever. So now how to ensure that vibrations are not felt? See, one vibration will be due to the sound that you cannot safeguard your building from. If sound vibrations are a problem, then you will have to think of erecting some barriers. But if the vibrations or from railway track is a problem, what I can think of is to try to go for some sort of isolation. So isolation can be that you provide some retaining wall type of a thing. So let's say here this is some ground. Okay, this is your natural ground. People are standing. So you go with a retaining wall over here. All right. And what you can do is in between your plinth and retaining wall, you try to conceal this space and try to fill it up with some damping material like sand, let's say. Okay. So all around this building, you create a moat. Moat means a partition, and try to fill that partition maybe with some damp proof material like sand, and that can act as a good vibration control mechanism for you. We have done such things in our industrial buildings. Of course, it did not have a problem from rail vibrations, but just because it had a problem of vibrations from the nearby buildings, that's why we had done such a thing. So maybe in this case also, you can come up with such a scheme where you try to have a pit all around the building and try to fill it up with sand. So at least the vibrations that are transferred from the railway track, they are sort of isolated by this sand layer. Okay. So this is what comes to my mind. And of course, here we are not designing our structure for the vibrations. We are just trying to detach our structure from the expected vibrations coming from railway lines. For sound vibrations, I just said you may have to install a physical barrier which will which may help you to cut down the sound vibrations. His next question is how to account for vibration loads for design of jack wells, where large pumps are installed in the wells and continuous vibrations are there. Again, I think the answer might be same, that you think of providing some detachment, and detachment can be in a way by providing a pit all around and fill it with some damping material like sand, etc. Okay, all right. So this was the questions asked by Mr. Ketan. Next question is from, just a minute. Okay, so next question is from, let's see who is. uh, Next question is from Nepal. He is a working professional. Acha, name is also Nepal. Okay. Steel design course we want and expecting discount. Yeah, so you can start with our basic course in steel design that we have conducted, and it's a very good course if you want to learn steel design from the basics. We have gone a lot of in depth with that course, so you could start with that course. Discounts, we don't have any policy of offering discounts to anyone, so there will be no discount. But yes, you can have a look at our course on our website. Okay, so that was his question. Any other question anyone else has? Okay, so Dhruv Panchal is asking any source to start learning PEB, oil and gas. So you can have a look at our course that we have done on PEB with focus on industrial shed-like structures. I think that will be a very helpful course for you if you want to learn PEB design in a proper manner with crane loadings, etc. You can have a look at that. Oil and gas, we will soon start, maybe after a couple of months, maybe, or within this first half of the year. We will start with a course on pipe racks. Post tension, right now, I have not seen any good online resource or course to start learning post tensioning, but there are some good YouTube channels. I am not able to recall them right now, but I have been informed that there are some really good YouTube channels which teach the PT design, pre-stressed design in a proper manner. Maybe you could have a look at that. And of course, there are books and documents. Although I don't have a good source right now available with me. Okay, good. Anything else? Oh, so short. No other question. Anyone in the live audience, if they want to ask any question, because only two questions were there in the Google form that we have answered. One we have answered from the email. So I don't have anything left with me right now. So if there are any questions, you may please ask. Yes, please. Any question, comments, query anyone wants to make? So right now, those who are watching this live, you can just write down in the comment section. Just type your query in the comment section of the video, live comments. Okay, so I think we don't have any query then. So it was a short session today. Okay, so I think then thank you so much for joining us. And since there are no other queries, we end today's session. So that's all for today. Thank you and bye bye. And see you next week, where we will try and answer your queries and questions, doubts, and difficulties. Okay, then. Bye.